Sound check. Passed. Hello world. My name is Stefan Pölz, aka Flashover, and welcome back to the next episode of Let's Code Roslyn. In the last session, 1 week ago, we have finished implementing so my computer was lagging. We've finished implementing the benchmarking types for I source generators, where we basically moved code to a shared project because the consumption of a source generator is quite similar to the I incremental generator that we built previously, other than that the source generator doesn't expose the metadata references collection. However, you can still set it. And it doesn't support driver generation options, which are used, I believe, for to disable certain steps of an incremental generator. And we started implementing the benchmarking types for diagnostic analyzers, where we got the basic shim basically working. In today's session, we will, since I now have published the new version of the package, or of the packages, because it's now multiple, version 0.2.0, I wanted to add this rather soon to the fco.templates that we have built in the previous session. Let me actually go to that discussion. Oops. Templates, yes, where we built a template for the .NET New that you can install via NuGet in order to get started with your source generator or incremental generator project. We have actually offered 3 different versions, one for 3.8, one for 3.9, and one for 4.0. So this is the different options that we can set. And we will expand that template now with a benchmarking project. Perhaps also a way how we could profile source generator, because actually in a session before that, we discussed, or afterward, not really more about the time frame, but we also discussed benchmarking and profiling of generators. So perhaps we also could include a mean of profiling, so benchmarking and profiling now as part of the template to get started with. Perhaps we could also make it optional so that you only get it if you opt in, or basically you could perhaps in the other direction opt out if you don't want it. Not sure yet. Okay. Now let's keep this open. Let's have a look at the new version 0.2.0 now includes also types for source generators, where we have a base package, the C# benchmarking base package, which then basically has two packages which depend on that one, C# source generator dot benchmarking and incremental generator dot benchmarking. And we will use for the 3.8 and 3.9 version the source generator package, and for the 4.0 version and above incremental generator. Okay, so let's jump into the templates project, which looks like this. So a templates package. Actually, let's have a look at the package at NuGet.org, because NuGet.org also tells us in this note here that this package contains a .NET Core template package. So this is not a classic dependency package, which includes public types that you can then consume, but it's a template instead. If we have a look at the content in the NuGet package manager, we will see that it has no lib folder here. There is only content, and this is arranged in a certain way that each template, or the root of each template, has a .template.config folder with at least a template.json file, and optionally a .NET CLI host JSON file, where the template JSON file includes the basic information about the template, and the .NET CLI host JSON includes information that's specifically the CLI is using. And there is also, if we jump to the generator template, it's always the same structure, and everything within the same hierarchy, or on the same level, and within the folder, so with the same level of the .templates.config folder. This is not part of the template. So we have these folders and their content and the solution. So this is a solution template. And we could also have an icon, which can be used by the IDE, for example, Visual Studio. And there's also an IDE host JSON, which is consumed by Visual Studio and or wider. Yeah, so this is how a template package differs from a library package. There's also some MS build options that you set if you have a look at the CS Proj. You set the package type to template. You include the content. You have no build output, so there is no DLLs involved. And yeah, so there aren't any dependencies to worry about. But if yes, so we will have a look at the Roslyn generator template. Let's go to the template.config to have a look at the template JSON. So this is where the basic information for the template lies, where we have, there is a schema to validate this JSON, author classification, which is used for but we can see that in the CLI and also in the IDE. We will actually have a look at all these options later when we see them in action. And somewhere we have a condition depending on which Roslyn version that the consumer of this template is selecting. Different files are included or excluded or renamed. Perhaps we will need that in order to allow different versions of the benchmarking package to be consumed. But let's see, perhaps we need it, perhaps we don't. And there's also parameters that we can set, for example, choices or Boolean flags where we could include whether the benchmark project should be generated or not. And yeah, that's the most important part of this. So let's get started with the solution. So since this is actually a solution template, we have a solution that we can open and implement the template with or extend the template. So let's jump to this solution. And yeah, let's run the test, see if everything is all right. And we will see a lot of, if we have a look at the code, or of the part of the template, we will see a lot of if definitions. So they will be all over the place. Like for example, if we have a generator, a source generator, in Roslyn 3.8, we must use the generator attribute. But in 3.9 or above, we may additionally pass language names to this attribute because it has been adapted. If we wouldn't have this flag, then this would fail for 3.8 because 3.8 doesn't include this constructor parameter on this attribute just yet. And so I think this means that in 3.9 actually you're capable of not only having C# generators but also Visual Basic generators. And yeah, so we may be using those if definitions. And yeah, then we also have a unit testing project. Those are actually the tests that we just executed. And there is a integration project, testing project as well, which really like tests. So the unit testing project tests the generator itself, and the integration testing project consumes the generator and tests the generated code. So yeah, let's add the benchmarking project. I will start with the same name because Roslyn.generator then will actually be replaced by the template by whatever name the user will be adding, but we will see that when we test it live. So let's add a new project. Since we will be using benchmark.net, this should be a console application, but not .NET Framework. Should be .NET Core. Yes. Let's call it .benchmarks. .NET 6. And let's jump to the benchmark.net website. Getting started, we created a new console application. We need to install benchmark.net. So let's go to the NuGet package manager, browse for benchmark.net. List version is 0.13.1. Okay. I agree. Okay, let's see if it's installed. Let's have a look at the... Do we want to set some settings on the cs proch. I want to turn this around, so we enable nullable, we have implicit usings, and the rest we don't need to care about just yet. And we want to include the generator. So add a reference to the generator project. And let's do a benchmark. So perhaps, yeah, I guess we also need, no, we do have a generator actually. So this is the generator that we want to benchmark. So we have here the Hello World generator. So let's create a file called Hello World generator benchmarks. I think in here I'm still using block scoped namespaces from C#9 and below, not the file scope namespaces from C#10 yet. Perhaps in a future version of the generator, maybe we'll be switching that. Offering both seems to be a bit painful because we basically need to offer both files twice, but perhaps we can then have this be a feature flag, but yeah, that's not the content of this stream. Okay, so we have the benchmarks. It should be a public class, and we have a benchmark. Actually, let's go to the benchmarking library that we have published, because we do have a example and I want to derive from that. Okay, so we create a yes, okay. So let's actually open both examples. So we have an example for source generators and an example for incremental generators. So this will be our first switch already, because we need the source generator type for 3.8 and the incremental generator type for C#. What did I say? For Roslyn. We need the source generator type for Roslyn 3.8. Did I say that? Not sure. And the incremental generator for Roslyn 4.0. Then we have a global setup where we set some source. And we initialize the benchmark with a type here. Let's pass in null for now. And then we actually run the benchmark. The invocation phase, and at the end we have a inspection phase where we verify that the generator, yeah, it's basically a bit of some sort of a test if the generator actually generated what we expected. Okay, so we need those attributes, benchmark.net attributes. We reference to the package, of course. So let's start with the source generator version. Let's add these to the benchmark project. There it is, version 0.2.0. Now we should be able to include the namespace. Yes, we are. And this is the hello world generator. Okay. So per default, we have the, per default we don't have the 3.8 source generator enabled, but actually the incremental generator. So we need then to have a switch for the 3.8 versions. So let's say we actually need to turn this around. Need to include this if 3.8 or 3.9, because those are the options. Perhaps I'll show this briefly. If we go back to the, let's go into the folder view of the Roslyn generator template. In the template JSON, we have defined those symbols 3.8, 3.9, 4.0 that the user can set via this Roslyn version choice here. We can select 3.8, 3.9 or 4.0. That then for the IDE, not for the IDE, but for the CLI version, we can set now this Roslyn version. So that's the same name as here. And we can set a long name and a short name, where the long name then is basically dash Roslyn, and the short name is just single dash .r. Then we can add any of these numbers, where 4.0 is the default. We also set that here. That's the default value. And this then gets available in the template itself as a looks like a preprocessor constant. Where is it? Yeah, so if Roslyn version is 3.8, we have this constant available. If it's 3.9, we have that, and so on. So if it's, or we could also say if it's not 4.0, or we say not 4.0. Let's see how we do it in the others, so to have the same, obviously use the same syntax. But we start with 4.0, C# incremental generator benchmark, and of course I now included the wrong package. We need to include this one. Okay, let's switch back to the solution view. Add the dependency to this brand new package 2.0 incremental generator, go. If we jump to the CS proj, here we need to do now a switch then. So we need to replace, so we set the incremental generator version, but then need to replace it for the, if we select 3.9 or 3.8, we need to replace that with this, so we can do some replacing, or we do some if here, not sure yet. Okay, and of course the hello world generator. Which is inaccessible to its protection level. So let's add, I believe we have a assembly attribute here. And I actually think in new MS build versions there's a shorter version for that. I saw this in a video recently, perhaps we can optimize this later. I think this was a video from Nick Japsas. Shorter version of this. But for now to do, we we set the internal visible true attribute to Roslyn generator benchmarks as well. Well, I guess we could, well, this is replaced. I think in the video, it shows we could also use something like assembly name. But yeah, perhaps we'll refactor that later to what the video from Nick suggests. Okay, so we got the benchmark. Now we want to initialize it with a new C# incremental generator benchmark initialization context that we, I don't have my, what's it called? I actually want to use that. I used to have this as a dependency. Yeah, but I don't want to have this public project, the generator depending on them. So let's go to extensions. Let's also published an analyzer package as an extension online. That's f0.analyzers, which basically implements a very similar feature that Writer has. Now I would need to restart Visual Studio. Don't do that now. To initialize members in an object initializer automatically. Now I need to go in and set those that I want to have manually, but yeah, that's all right. So we have some source, which is just a string. What does also our hello world generator actually do? Let's have a look at the, I can't exactly recall. I think it's looking for partial static methods and implementing a hello world string, but let's see what it actually does. Let's have a look at the integration test. There we will see. We have a greeter. Okay, so we have a partial class and a partial method. And if we go to the definition, then the generator implements that class. Well, not implements that class, but offers a partial class to this compilation and then offers the implementation for this partial method. Because we actually need an implementation, because we have the public keyword for this partial method. That means the new C#9 rules apply that require you to actually offer an implementation. If you don't have the public keyword and you don't have an implementation somewhere, then it basically will get stripped out. But for such, that was the rules on C#8 and earlier, for those public partial methods, you can only have void and no auto return types. Chandu16 is writing, someone doing .NET finally. I'm happy that you're joining in. What are your benchmarks? I am benchmarking. So in this project is a .NET New templates project that generates for you, similar like you could generate a class library or a test library, which is included in the .NET SDK. If we fire up the Windows terminal, we can say .NET New, perhaps also .NET New -- list. Then you see all the templates. Those are all templates that are included in the .NET CLI or in the .NET SDK. And you can extend this. You can install your own templates via locally or also via NuGet. And we want to extend a template that we built in a previous session with the benchmarks. And so we are generating a source generator template to get kickstarted, to have everything set up so you can write your own source generator rather quickly. And we also, in the previous session, we built a library to benchmark these. Well, actually, we are using benchmark.net to do the actual benchmark, but have a helper library which facilitates setting up the test, setting up the inputs such as the source and the options that you want to pass into to this generator. We will see this, how this is applied in just a second, 2 seconds, 5 minutes. And then invoking the benchmark under the hood using some generator driver types in order to trigger the generator, and then at the end you get a familiar benchmark.net report. So we're testing Roslyn source generators and incremental generators, benchmarking these. Okay, so, and in this, now to come back, in this already existing template, we have a generator which, searches for within partial classes, searches partial string methods, and implements them, saying hello world. I think actually also the attribute. Yeah, I'll actually build this. So I need to slap this attribute on this method, and then the generator generates a hello world implementation for that. And exactly that generator we will benchmark now. Let's have a look at the implementation. So here we have an incremental generator, which is the Roslyn 4.0 and above, which has been added in or which is compatible with the .NET 6 SDK and above. And we have a post-initialization step. In a previous session, we discussed what a post-initialization is. This is executed unconditionally. So you don't have the compilation available here. You can just put out some source code that you basically unconditionally want to generate. And this is then the initial. So this is after initialization. And then afterwards, you set up a pipeline, which then within the execution phase, then actually generates the source code. So we set up a pipeline where we find all method declaration, and we have an isCandidate method where we see if the attribute list, there's at least one attribute, it has 0 parameters, and it has the partial keyword. Perhaps we could actually also look for, maybe I'm adding this later, check if string returning. What do we do this? Oh no, we do this check down there. Because, well, why do we do this check down there? Because the user could write either string, which is a keyword, or system.string, which is from a C# point of view, so from a syntactical point of view. These are different. From a semantic point of view, it's the same, because they both actually then get compiled to the system.string from the BCL. So this is why we don't include the string in the semantic check, but later on in the syntactic check. I'll come to your question just in a second. And we have the syntactic check here, where we check, does this return a string? We figure that out. We get the type of this method and check this if the special type is actually string, which now doesn't matter anymore if it's the string keyword or the system.string or just string. And we check if it has the hello world attribute. So we get that attribute, see if it's declared on that method, and then the syntactic check has passed. We return the method, and then in the execution phase of the generator, actually generate the source code, where we create a builder, we set auto-generated nullable and able, which is always good practice. We need to put this generated type in the same namespace where it was originally declared, and we extend now this, or we implement now this partial method with the hello world string. There it is. So it's just a string that we generate, and then we add it at the end to the compilation via add source. You are benchmarking generated code by C# source generators. No, not benchmarking the code that is generated by the generator, but actually the generator itself. So the code that we are right now looking at, So this is the code that the generator code itself implementing incremental generator, which is in the Microsoft.code analysis package. So this is a Roslyn plugin. We actually benchmark this. And this is what the library that we built in the previous stream and will continue to build in the follow-up stream is facilitating. How do you think source generators will be useful? I will come back to this after we got the first benchmark running. That's because I need to think of a shorter answer other than the next 1.5 hours. And I'm also quite biased, so I try to have a more objective answer already. All right. So let's write the benchmark. Okay. So the input, we actually can go to the integration test, which serves as a great example. We have so we put some namespace. We have namespace Roslyn generator. Well, we don't really need a namespace, but I prefer having a namespace. Benchmarks. Doesn't really matter, but to have like a complete example. In this benchmark, in this namespace, we now have a class. This class, and we see the input for this benchmark is actually just a C# code that now by this benchmarking library gets compiled, put in as input to the generator, and the generator then, or the input gets prepared for the generator. The generator is then actually generating code in the invocation phase a lot of time to receive the output. And we will then actually see what the generator does, because we also have a cleanup phase where we can do basically a not as thorough unit test. Not unit test, but test. So we have an internal, let's make it public. For this example, public static partial greeter. We have the hello world attribute. I think for that, do we need that hello world attribute is created by the generator in a namespace, I believe. And the namespace is roslyn.generated. So we also need to be using that. So we actually need a using. I comment this out for now. So we see in the cleanup phase that errors get then put out to the user, so that the invoker of the benchmark knows that there was something wrong with the generation, something was unexpected, and the benchmarking result is actually perhaps not meaningful, because something failed and then the code didn't really get executed, or less than actually expected. And then we have a partial string here. Yes, a partial string returning method. So this is the input for the generator. We set the source. Do we need to set anything else? Because we have a lot of input we could set. Perhaps let's go to this type. This is what we could offer the generator as an input. We could have, so we have like one source. We could have additional sources. We could also have additional texts, which is not C# code, but could be like a JSON file or text file. Some pass options, which may include, for example, which version of C# we are using, some options to the compilation, metadata references, perhaps which BCL version we're using, or which target framework we're using. Are we using that standard 2.0, .NET Framework 4.7.2, .NET Core 3.1, .NET 6, whatever. Some analyzer config options, which could be from MS Build or an editor config or a global config. And here the driver options. These are available for the incremental generators, but not for source generators, where we could disable certain outputs. For example, we could disable the post-initialization phase, and then the thing that we register in the post-initialization, which is the attribute, would not be generated. But we don't need anything from here. Then we invoke the benchmark, and in the cleanup, for a bit of a test, we now see if we actually get what we expect. So let's create here an error source. Now we expect in the same namespace a type, I think this time without the public keyword because it's not necessary, without the attribute. But now this method implementing hello world. I will have a typo here as well. Hello world. To see also the diff, then what the inspection phase does. So this is the source, the output source that we expect, but it contains of two parts. First part is this, the second part is the source, and the first part is the hint name, because every source that a generator produces also has a hint name, which is used by tooling to display, or perhaps also could, if enabled, produce a file from. Per default, source generators do not produce files, but you may enable this, that actually a file is produced. Or in tooling, we will see, if we go to Visual Studio, to the dependencies, then we see, if we follow the dependencies, the target framework analyzes, the generator now generates these files. And this will also be added in the next version of Roslyn. This is why I'm now using Visual Studio here. Roslyn Rider 2002.2, I believe. It's currently in RC, I think. Will then also display the dependencies that generated file. And this is now what the tooling uses in order to give it a name here. This file doesn't necessarily exist physically, but tooling gives it a name. And so we expect something, not sure yet, so I just write something.g.cs. So we will have just another source of error. And then we inspect that. Actually, let me inline this as well, makes it a bit shorter. Oh, why am I doing like this? I'm using an IDE. I can do inline, can I not? Yes, excellent. Don't need those braces. Parentheses. Those are parentheses. So we have, so I tweeted the other day. So we have the round ones are parentheses. The curly ones are braces. Generics are chevrons. And the array things are brackets. At least I believe from a C# language point of view. Okay, let's run this benchmark. So I'm opening a terminal here. Benchmarks should be run in release mode, .NET 1-C release. And it prints out hello world because I should have a look at the program.cs. Yes, this is not expected. So let's go to benchmark.net because they have a code snippet there for me as well to use. There it is. I don't really care about the summary here. We have a benchmark runner and we want to run the hello world generator benchmarks. Now let's run it again. Generator is starting up. The benchmark.net is starting up, and we have a I expected. So we have an unexpected number of diagnostics, but let's see what we have. partial method greeter must have an implementation part because it has accessibility modifiers. The hello world attribute could not be found. Are you missing a using directive? Yeah. So we have several issues. The hello world attribute is actually expected because this is commented it out, and this is now what happens in the cleanup phase or in the inspection phase of the benchmark, which basically tests for what we expect, and we per default expect no diagnostics, so there shouldn't be any warning or errors, but we actually have one because in the input this hello world attribute isn't found because we haven't imported the namespace. So if I comment this in, it should be found, and now the generator actually has this attribute at hand and can actually generate the missing part, which is basically the follow-up error. The generator couldn't generate anything because this attribute was unknown. So let's run it again. I hope I saved. And yeah, so the cleanup phase is happening at the end. We have more errors, some exception during the cleanup, which is our inspection phase. We have unexpected numbers of syntax trees. So we expected 2, but there were actually 3. So this is the first syntax tree. This is the second syntax tree. So where's the third one coming from? That I don't understand. Okay, I guess I need to add a better output perhaps to, if there is more syntax tree than I expect, give some additional information of which one, because now that's quite difficult to fix. I will add myself I think I have somewhere to do already for the plan for today. Where do I have it? No. I'll write it here. To do benchmarking library should give more info if the syntax tree count is unexpected. I will open an issue perhaps later on. Maybe we tackle this later or in the next stream. Okay, but what am I doing wrong? Why do we expect? We expect 2, but there have been 3. Yes, because the generator also generates the attribute. So we also need to check the attribute. String attribute. I will actually grab that from the integration test because we can F12 this attribute here. So this is what the generator generates. The attribute in the post-initialization phase, because that's also part of the generator. And this is what we expect, the attribute that gets emitted. So we need to expect this as well. I will have an source. I think this is now, I don't know about the name, but let's have here, and now we do additional sources. This will be the previous one, because the post-initialization phase is executed first, so we need to have this here, or we do it all in the additional sources. Doesn't really matter. I think the order is important. Let's run the benchmark again. Now it should have this. Now we actually pass in the expected inspection phase 2 additional syntax trees to attribute and the expected implementation. with the original amounts to 3. And yeah, so now we have some hint names which differ. Something, we call it something, but it's actually helloworld.g.cs. So the helloworld attribute.g.cs is the attribute that we emit. And the other one is neither called something.g.cs, which will come to just a second where that benchmark has finished. I like trailing commas because if we then later on add something here, in Git it's actually just a line added. If we don't have a trailing comma, then I would need to add this comma, and then I have basically 2 lines changed. The line where we added the comma and then the new line. So this is why I like to put trailing commas in object initializers and collection initializers. Okay, yeah, so the one is called greeter.helloworld.g.cs, not something.g.cs. And yeah, now we have still this as an expected error. So we will see in just a second how the diff is displayed there. But what I see, I always need to run the entire benchmark. Perhaps I also want to do debugging, because you can also debug a benchmark, but not by default. Because if we would go ahead and select this benchmarking project as a startup project and are now in debug configuration, and we would run it, benchmark.net will complain about, hey, benchmark is only meaningful if you run it in release mode. It says here, if you own this dependency, please build it in release. But if you explicitly want to enable debugging, there is a it's not a trick, but it's a implementation that I like to use. I'm going to a different project of mine. So this is an actual generator that's also published via NuGet. And in here, for the benchmarks, in the program CS, I will grab that. So let's come to our program.cs, insert this here, include all the missing usings. This does more than just enabling debugging, but I'll come to that later on. We don't need this one. Okay, I should also have a, let's put this into a namespace. That's a namespace, isn't it? Yes. Okay. So the most important part is if the debugger is attached, we actually use a different config. There is a debug in process config. So if we actually run it with the debugger attached, so I hit either F5. I don't hit Control F5 because that runs in debug mode, but without a debugger attached. So I run it via clicking there or just hitting F5, so that where do we see it? We see it here. So Control F5 launches without debugger. This would mean debugger is not attached. But just F5 or start debugging has the debugger attached. So this is true, and we select the config, the debug config, which means, okay, actually let me set a breakpoint that we see how we can, so that we can also debug benchmarks. Okay, I will select the benchmark, and we hit the breakpoint in the benchmark. So the result of a debugging benchmark is not all too meaningful, but it this is how we could do debugging a benchmark. Which brings me to the idea I should also add, where did I put this to do before? I put it in the program, didn't I? Yeah, and I overwrote that. Not so smart. There it is. So we now actually get the exception, yes, from the invocation phase. So we add, perhaps you should also, what's that called? Add the source code to a NuGet package. Source output link, source link. Okay. Oops. Okay, we have to. Oops. No, I missed. Okay, I didn't think. Threw some code away. Yes. All right. But for the actual fix, to see the actual problem, do we see it here? No, I discarded that. So let's run the benchmark again, because we have one error left. Then the benchmark should be fine. There it is. We have, let me change the color, blue perhaps? No, blue is bad, pink. We see that we expect to have a file scope namespace, but we're actually using a block scope namespace. So we see here the minus is what we expected, but the plus is what was actually there. So we basically see a diff between the code that we expected and that we actually had. So we expected this, but it was actually hello world. So let's fix that as well. From the inspection phase, so we actually have a block scope namespace. Oops. We have a correct hello world here. And we also have the auto-generated and nullable enable on top. And this may just be all right now. Let's run the benchmark. No, there's still one issue because, okay, I have namespace, and I'm missing the, oh, I'm expecting a static keyword, but it's not required here. So let's remove the static and remove the double namespace keyword. And now we should be good to go. And now we are benchmarking the source generator, or in this case, the I incremental generator of the template. While this is running, to come back to the question, how do you think source generators will be useful? I guess the more objective answer is to have a look at what Microsoft is offering in .NET 6 and in upcoming .NET 7. So there is a logger message generator, which has been added in .NET 7, in .NET 6, where you basically have a partial method, which takes a logger, and you slap the logger message on it, and basically then is the same as you would write the extension method, or invoke the extension methods, because you would write log critical with some message template. And so you, instead of that, you say logger message, log level critical, and that, the message template, which then results into a more optimized version, because under the hood it uses fast logger Microsoft, not sure, high performance logging, Under the hood, it uses logger message define, but also if guards that code in an if this log level is enabled. And this has some performance improvements. I went through them in a different video. So this is actually, you can avoid tedious code that you already know. With logger message.define, the pattern how to write it, it's always the same. So you can have a generator generating it and also generating a faster version. Because if we invoke the extension method of ilogger, for example, log critical, that takes as the parameters as, to have an example here, as these holes that we place here actually as an object argument. So we always allocate an object array. So we always allocate this array and perhaps also have boxing. And so this is faster. There is also in .NET 6 a JSON generator. .NET 6. There is a blog post about that, which for system text JSON, it then offers it implements a lot of code, a custom serializer context for your type, which then they do some benchmarking down there, which then is measurably faster. And .NET 7 will have a regex generator. Where it basically, you then have a regex attribute, I believe. Okay, this is a not sure if well, there is a blog post. Let's have a brief look at that from Gerard. I need to look up the Gerard Barré. I hope I pronounced the name correctly. Where you then slap a regex attribute on it, have your regex there, and this now compiles the regex. It is all at compile time. So at runtime, even the first run. So because if you have like a regex that you can pass the flag compiled to it, but still the initial one will take a bit longer. The subsequent ones then are faster, but the initial one needs to basically generate and compile that, and you can then avoid this startup hit by having it all done during compile time. So with a shorter answer is, how do I think source generators will be useful or are useful already? They avoid tedious implementation and potentially also avoid reflection with a more specific implementation for the consumer code, which then increases performance. So the user writes less code and the generator potentially creates faster code. Okay, and while that, the benchmark has completed, and what we see, we have here two runtimes actually. This is also what's come from the code snippet that I copied. If we jump to the program.cs, we can add different jobs. So we have the 472 runtime and the .NET 6 runtime. Also add some statistics to it. We also output it as an ASCII doc. Yeah. Additionally, because this is then also the result is not only printed to console, but also put up to a file. And we see this is the performance of our benchmark. It allocates some kilobytes, and we have the mean, and as usual with benchmark.net results. And now we're benchmarking actually the source generator, or the incremental generator in that case. Because it's important that generators are fast, because they run during every compilation. For example, on every .NET build, or in a IDE. If you write in the IDE some code, then it may be generated even per key press. So the generator should be rather fast, and also listening to cancellation. because cancellation in .NET is cooperative. All right, this basically actually implements the generator for 4.0. However, if we would, let's give it a try. Let's see what's happening. Now I need to remember how to actually install this template locally. I'll jump to the, perhaps I noted it in the previous notes, in the previous discussion, when where we actually initially built this template pack. So we actually have unit tests, so we should run them first, see if I didn't break anything. Let's have a brief look at the unit test. They're basically testing, no, that's the test of the generator, sorry. I need to go to the, let's close that. Das Holzauge. Thank you very much for following. It's German. Thank you very much for following. I appreciate it. Where was I? Das Holzauge got me off track. Yes. Trying to run the unit tests of the generator pack. Let's have a look at these, where I am using this package, boxed.NET new test, where you can basically, so we have different inputs here, so I try different combinations of the generator for Roslyn 3.8 with MS test as testing framework, 3.9 with NUnit, 4.0 with XUnit, and we create an actual temporary directory. Then we get those arguments, put them then into the .NET new, which actually then we can, so we create here the template, we run a .NET restore, .NET build, and .NET test, which runs then the tests that are also generated by this template, and then awaits expects everything to pass. However, we have a failing test, which is perhaps indicating what I meant. Let me copy this into a bigger instance. What do we see? Let's zoom in. We see that build failed. The type cannot be used as type parameter incremental. So the hello world generator, this is because we have two tests which are not using incremental generators, but we still have the incremental generator there. So it will not pass for these. So we need to go to the new follower, Usualnik. I hope I pronounce it correctly. Thank you very much for following. I really, really do appreciate it. I really do appreciate it. Yes. Yes, so we have a failing test, which is good, which indicates that we must jump back to the template. What we anticipated, we have a comment here because we're using the incremental generator package also for the 3.8 and 3.9 version of the generator, which is iSource generator. So those are two different interfaces. So we need to, the simple version is to also include that package. We should only include the package really needed, but we will optimize this afterwards. Let me add a to-do here. Select on select correct package. And so this will be 3.8 and 3.9, and the other package is 4.0, the version of Roslyn. Yes, so we also need to include this type. But now we have a bit of a conflict. Yeah, so which one to select? I want to do it similarly that we have in the other places. So we have the incremental version per default. This is not guarded by any preprocessor directive. But the 3.9 and 3.8 version we have if Roslyn 3.8 and so on. So let's actually, I will grab this. So we can use here, so .NET New template, the .NET New template engine actually evaluates these preprocessor directives. And so you can actually, so this will not be part of the generated template when you do .NET New. The templating engine will replace that. So we have an if here, followed by an end if. And if we have either Roslyn 3.8 or 3.9, then we go with this one. Otherwise, okay, I need an else. We go for this. Okay, so this may already, we could test that. If we go to the CS proj here and add, I think that's an item group, what's it called? Define constant. Let me briefly look that up. MS build define constants. Define constants it is. So if we define constants, and we also always like to include the previous constants, and we say if it's Roslyn 4_0, we will see the incremental generator being selected. But if we set it to 3.9, oh, it's not all uppercase. Is it case sensitive? Okay, this is not in item groups. This is in the property group. Yeah, and now we saw up here it jumped to the other one. And if we have 3.8, we still have the source generator version, which comes from the source generator package. And if we set it back to 4.0, this should switch, and it switches. Excellent. Okay, so this works as expected. I keep this for now, but I must remove this before publishing. What else do we need to select here? I guess the rest is, yes, this type, of course. So we basically need to grab just that again. Perhaps I showed the error before. If we go to, I should have kept this open. If we go to 3.8, for example, this initialization context is not called initialization context, but is not incremental generator initialization context, but source generator benchmarking initialization context. So let's grab this construct again. And in the case of 3.9, we will have the I source generator initialization context. And in case of 4.0, it's the incremental version. Okay, but those two initialization contexts are quite compatible. The only difference is that the incremental version also supports driver options. And I guess the same goes for the inspection context. So if we switch to 3.8, this shouldn't compile anymore. Yes. So we grab this preprocessor directive one more time. Oops. And we in the case of 3.9, we use the source version of it. And in case of 4.0, this should switch to the incremental version. Okay, this should now build just fine. And if I remove, let's remove that again and go run the unit tests. We go to the template and run the unit test again. Which now again, create a temporary file, generate, basically does a .NET new in this temporary directory, does a restore, does a build, and does a test. And if everything succeeds, it should turn green any second now. And it turned green. This is why tests are great, and this is why I really, really like this package. The boxed .NET new test package, this really, really makes writing .NET templates testable, which is great. And all tests are green. This is cool. I somewhere have actually, I wrote somewhere a to-do. I wonder where I put this. I put it here, yes. So a bit of a to-do list. We added the benchmarking project, yes, for both, that's cool. Options, we perhaps need to update the new template options. Not sure if perhaps I come that to later. Yeah, okay, we tested it. We unit tested it. The global tool I show later. Now we also want to install it locally. I hope I can remember. So we can install this template locally. We go to the CS Proj level. And say, let's duplicate this tab. .NET new -- help. So we gonna installs a source or a template pack. So perhaps we can say installs the current folder. I think that's like so. And yeah, cool, success. So it now installed this new template pack, and we have the new template available. So if we do a .NET new -- list and we zoom in a little, it also lists the new Roslyn generator. So we can go now to some directory. How can I create a new directory? I actually don't know. Add item. I'll do it manually. Let's create a we call this playground. And to the .NET new Roslyn generator -- help. Then we see the options. Let's create a -r Well, let's use the default 4.0 for now and see if this is generating just fine. So in the playground, I didn't. Okay, I failed. What was generated? Source. Anything else? Source.solution. Yes. So I should switch to the playground and now install it. Let's see if it looks fine. So we have a solution. Oh no, there it is. So we have the solution. I didn't pass a name, so it gets the name of the folder. So the replacing works for the benchmarks. And this CSproj, let's have a look at the benchmark at the CSproj. The benchmark is using incremental generator. That's good. But we still have both packages. So now we should have the incremental generator package and the source generator package for the 3.8 and 3.9 version. Actually, I need to vice versa this. Okay, let me clear the playground. Let's duplicate this tab and do a .NET new -- uninstall. And with this command, we can uninstall this template pack again. So now it's no longer available. If I do .NET new Roslyn, it's not found. So now change it, install it again, and try it again locally. We need to go to the template. Oops. Okay, now I'm not 100% sure how to select here the correct version. I'll have a look at what I did in the other CSprojs. Been some time. We don't select anything here, but in the test project, we definitely select something in the unit test project because we select the correct packages for testing. So example, MS test or NUnit and so on. And so basically via conditions. All right. But I basically offer a one, because we don't have those for the, like the local debugging experience, we don't have this available. So I offer like an explicit MS test and NUnit switch, but per default, if it's neither, then we assume it's XUnit, and then we have our default, which is in our case the source generator. Okay, I will actually grab this, paste it in here. So we always need benchmark.net. And we only have two. So if it is, oops, let me add this. So if it is this or that, okay. Now we need to go back to the template, get the configuration that we have. So we are using those symbols. Let's search for symbols. Here they are. So the symbol that we are having is unit test. Testing framework is XUnit. So it's the Roslyn version. So we can depend on the Roslyn version. If it's 3.8, 3.9, or 4.0. All right. Jumping back. So Roslyn version. We'll zoom out a little. So if the Roslyn version is 3.8 or the Roslyn version is 3.9, then we will use the source generator package. However, if it's not 3.8 and if it's not 3.9, it's like the opposite, then, because maybe later on we will be adding a new version. I actually plan to add a 4.2 version as well, because in Roslyn 4.2 for the incremental generators, metadata references have been fixed. So I want to offer this as well, and then I don't need to have to change anything here. So if it's neither one of the ones which require source generators, we can use the incremental generator. Let's check this one more time. We have if the Roslyn version is 3.8 or if the Roslyn version is 3.9, then source generators. If the Roslyn version is not 3.8 and not 3.9, which means 4.0 or anything else, we have incremental generators. Okay, that looks good, and I believe that clears all the to-dos that we had. Let's jump back to the template pack. Before we do a manual test, let's run the automated tests. Well, in the automated test, I really don't check for the if there is like too many packages included or the version of it. So we need to confirm that manually, and it fails, which is not good. There was a conflict. Why did I not have this earlier? Okay, okay. So if we have the Roslyn 3.9 version, it may be connected to seems to be connected to the, no, I'm not sure. Benchmarks. Found conflicts between Microsoft.code analysis. Why is that? It's for the 3.9 version. So the 3.8 and 4.0 are fine, but if we're having 3.9, we have a version conflict. This may be because, let's have a look. Let's inspect the packages. Do I still have this open? There it is. So the incremental generator package depends on Roslyn 4.0. But the source generator version, it depends on 3.8. That's right. That means in our benchmark here, we have 3.8 dependency, but the generator package, okay, here I solved this differently. The generator package includes Microsoft Code Analysis C# Workspaces 4.0.1, but I guess I replaced this. I have in the templates somewhere, definitely some replacement. Is it called replace? Roslyn version generator. Yes, we replace 4.0 with 3.0.9 if the Roslyn version is 3.9. So that now means, that now means that this generator package, or the package, or the project actually containing the generator, depends on 3.9. But the benchmark project includes now a project which depends on 3.8, which is now a package downgrade. So in here, we need, in case that we are on 3.9, we need to add an explicit dependency to 3.9 here as well in order to fix that issue. Okay, so this is 3.9 exactly. Okay, I'm going to the benchmarking project, having this 3.9, probably that's all I don't need here, to basically bumping this version, but not, this should be also conditioned. We don't need this all the time. We only need it if, so let's grab this condition here. We only need it if the Roslyn version is 3.9. In the case of 3.9, we need to manually update this package to the higher version so that now the generator is using 3.9, and this benchmark project, which depends on the generator, actually here we have a 3.9 here and a 3.9 here, which is good. Previously it was a 3.8 here and a 3.9, no, other way around. We had a 3.9 here, but the 3.8 from here, where we had the downgrades, but now we bumped this to 3.9. Now everything is good. There is actually a NuGet feature for that added in Net 6, but I guess this goes in combination with the, what's it called, global package management, where you can have a directory.packages.props where you can centrally manage NuGet packages. But I don't really want to use this in this template, at least for now. So this should be the solution. Let's go back to the template pack and run those tests again. So tests are always super helpful. They do take some time, 15 seconds, 20 seconds each, because they do install the the template, generate the template, do a .NET Restore, .NET Build, .NET Test on it. So this is why it takes some time. But I guess running these tests taking perhaps a minute is better than doing manually, installing the package manually, generating a template for each 3 versions, and then manually confirming if everything is all right. So automation, yay. Okay, cool, all the tests are green. And let's also do the manual test, repeat that. If everything works great, let's jump back to the console. We will first install the template pack. We will .NET New Roslyn generator -- help. Let's now install the version 3.8, which is -r 3.8. And let's confirm that the benchmarks now actually, let's grab these 3 files. Ooh, the artifacts are also part of the template. We need to eliminate these. We need to ignore them. I'll come back to that later. We see that we are using the source generator version. That is correct. This looks great. Well, the to-dos I should get rid of eventually. And we are using source generator here, but we don't have this manual version bump of Roslyn. But if we go ahead, let's clear the playground and run the generator again with 3.9. Perhaps let's also give it a name, my super generator. Now it should also have the name. And now the benchmarks. Let's open these 3 files again. In the CS proj, we now have the 3.9 version bump, so everything is cool. Perhaps for one manual test we could actually run. Should we run the benchmark in the manual, in the automated test as well? But the benchmark takes some time, but well, perhaps we should. Let's do it manually for now. .NET run-c release. And with an error. Unexpected number of diagnostics. We have some braces are missing. Okay. Why didn't I see this in the... So okay. That means we really need to run the benchmark automated as well. So how we can do it? I'll copy these. .NET async, or perhaps we can just add it to here, and we can .NET test, and we say await project dot still like a manual store one .NET run. Perhaps we can pass arguments to .NET run. A relative directory path. Okay, this readiness check, this seems to be more suited for an ASP.NET Core application, not for a console application. No, we can't really do that, I'm afraid. Perhaps there's a newer version of the package. There is not of the boxed. Maybe there's a new pre-release. Neither. Let's go to the documentation. Maybe it shows something. So it has some status endpoint. Yeah, this seems to be for ASP.NET Core applications, API templates, .NET Run, HTTP client. Yeah, it doesn't look like we could do this for a console application. To run it in release mode. Well, that's a bit unfortunate. So we need to do a manual test. And how do we do the manual test? We'll go to the benchmark project. We will define constants. Roslyn 3.8. Oh, it's 3_8. And run it manually. .NET run-c release. The namespace could not be found. Okay, because I define, yeah, so this is not working like this. I will put this down here. Okay, I need to do the same. I need to do this everywhere, don't I? Just to get it right. No, still a build error. Ah, okay. 3.8.0. Still. What am I doing wrong? Here. So because I replace the version here as well. Okay. I replace all the, doing the template generation, replace all the 4.0.1s with 3.8.0s. Okay, now it compiles. Let's run the benchmark. Yes, okay, there we have it. So that seems to be the some braces are missing. That would be the file scope namespace here. Because we are using language version. Okay, if we would like to support this, we could say parse options, new C# parse options, and they allow yes they do, and they allow passing the language version. Because I guess since it's guess we're using here, yeah, some lower version .NET framework per default. Yeah, we don't set the language version, so we have like C# 6 or something. Yeah, this won't work. If we set it to, yeah, we don't even have 10 here available because we're using it was in 3.8 and was in 3.8 it doesn't have C# 10 yet. It says C# 9. Okay. So let's fix this by converting this into a block scope namespace. And let's run that one again. Now it seems to work. Where I now also tested one more time for 3.9. Okay, there's a bit of a manual check now, but I just want to be sure. Three, 9, 3, 9, 3, 9. .NET release. I missed somewhere something. This one, because this is not set. Need to get rid of this condition here. Okay. Other ones, and let's do a, just to be sure, of 4.0 as well. Yes, and yes. Okay. And one error to namespace. Oh yeah, okay, now we need to use the other. Did I miss some Roslyn for Zero? I did define Roslyn for Zero. Why is this not? So because, yeah, the package of the benchmark, this one isn't evaluated. So let's do this manually. Oh, hold on, never mistake you. Source generator. It should be incremental generator for this one. Okay. Yeah, now we got it. So now let's revert all that we don't need. Okay. That's all right. That's correct. And this should be 401. It compiles. Let's go back to the template pack, run the unit tests. They should be fine. In the meantime, we will uninstall the template. We install the latest version. And clear the super generator here. For the manual test, let's run 3.8 again. My super generator, let's do a .NET build. If now I'm doing it manually, but okay, the .NET build and .NET test, it is actually tested by the unit tests. So let's check out these. They're still running. But the benchmark is not tested by the unit test, so we need to do that manually. I'm afraid. Try to figure out the automatable way. That would be great. So we are here. Let's perhaps duplicate this tab. Playground. My super generator. Go into the benchmarks, .NET run-c release. This should work now. It looks all right. Now let's clear that directory. Install 3.9. Run these benchmarks. They look good. And so I'm not waiting till the benchmark completes, but just see if the inspection phase, the cleanup passes. And one for 4.0, which is the default. Oh yes, I need to clear the directory first. And .NET Roslyn succeeded. Try to run the benchmarks. Look good. Okay, cool. Let's uninstall the template again. Perfect. Now let's do a .NET pack where we will see that in the generated package, we still have one issue. If we have a look at the content of the Roslyn generator, we see in the benchmarks also includes the results that we currently have. So they should not be part of that output. So let's fix that by having a look at the CS approach of the template pack. We can exclude things here. So we already excluded the bin folder, the object folder, the .vs folder, test results folder. I guess I need to also test this for writer and see if there is some temporary files for writer that may be added. We'll do this. Let's see. Time is running out. I'll do this off stream. Writer exclude potential writer temp files from the template pack. Okay. And we want to exclude let's add another part there. I forgot the name. Let's go to the benchmarks. It's benchmark.net.artifacts. Okay. Now let's do another .NET pack and see how this looks now in the NuGet package explorer. So I've installed this as a Windows Store app, which is pretty much the same as the online version that I showed earlier. And now in benchmarks, they are not there anymore. So we have the CS files and the CS proj. Let's have a look if they look all right. So benchmark program. Okay, those to-dos I should fix definitely. Okay, and looks good. Cool. And now we added benchmarking to the benchmarking template, the benchmarking project to the template of source generators. So I would like to keep it like that. I want to include them by default. If then the user doesn't want them, they can always remove it. And perhaps later on, if somebody complains, hey, could you perhaps offer a switch to exclude certain parts of the template, then let's add them later. But I want to give everything per default. Good morning, Eternal White Fox. Some dependencies to update. Let's have a brief look. While edit, perhaps we could also look at these later. Example project for debugging. Yes, we will do that. Unit testing, we tested the unit test. We tested locally a global tool. We will do that as well. The documentation, I do this off stream and I still have to do the writer thing. So I will add this to my other notes. So there's two things left to show today. So I'm looking for my notes. Where are they? There they are. Okay. Actually, let's put them out of there so I don't forget them. I put them here for later. All right. Yes, let's add a example project for an entry point for profiling or debugging a source generator directly. So let's add a new project. Console application. Yeah. Let's call it, well, actually, No, yes, console application. Roslyn.generator.call it example. .NET 6, where we will actually put this type here again. So we have a, we need to consume the generator. I grab this directive here for the example project. Move these around. Okay. Now we should have the generator working and emitting this attribute. Not yet. Let's see if for the example the generator is actually working. It is. It's generating the hello world attribute, so it should be available. Using Roslyn generated. There it is. And the generator now should implement this hello world, and we could console white line the result of hello world of greeter.get hello world. And let's put this as a startup project. Set a startup project and run it. And with build errors, must have an implementation. Yes, but the source generator should provide it. The source generator has an issue with file scope namespaces. Okay, that's a bug of the generator. I had myself another to do. Example generator has a bug when the type containing the method with the hello world attribute is in the global namespace e.g. Yeah, it's in the global namespace because we have no using. So we can fix this here by going into namespace. But namespace, let's use this. But top level statements can't be in a namespace, so I guess I need, for this example now, an internal static class program. So I'm not using top level statements, have a private static. I haven't written this manually in quite some time. So void main. Now the generator should generate it in that namespace. And it does, which is great. So we can run it. Yes, we can. There it says hello world. And we want to offer now a debug method. So in Visual Studio, this feature is not supported by Wider.NET in the preview, not in the preview from 2022.2 neither. But there is a way we can add a profile to the generator. So we go to Properties, Debug, and I guess we click here. We have here launch profiles, and we add a launch profile, which is something like a generator kind of thing. Add new profile, Roslyn component. There it is. We can add a Roslyn component profile. And we can set a target. So the target that the generator should be loaded in and then executed. We use the example. Okay, this generates now in the properties directory, a launch profile, launch settings.json. Actually, I will get rid of this and call this here. Okay, and we see this is a debug Roslyn component and targeting that executable in our case. So now we can also, if we set this target, so we have the generator here. We have a target, and now that means we can, although do set a startup project, although this is not a console application, this is a library, we can now execute it with the debugger. And that now launches the generator. So if we set a breakpoint in the generator, we will hit that by doing, I hit F5 or I click the button up here, and we're hitting the breakpoint. So this is how we could, from Visual Studio, debug a generator. I personally preferred to do it from a unit test because that it's a way more focused example, and then you also have this test automated. But this is another way I wanted to offer it as well, to have a complete thing, because we could use this for profiling. I think it's Alt F2. Yes, it is Alt F2. We can use the startup project. Yes. And let's do CPU usage. And we can now start a profiling session. I think I also showed this in a previous stream, but soon we will end up with a profiling session where we could then profile potential performance bottlenecks within the source generator. In order to have this debug profile work, it requires some specific version of Visual Studio. It hasn't been supported from the beginning. What's that? So it's in Visual Studio 2019. What's that? 16.8 when source generator has been added. So it's a later version. Yeah, but it's in 2022. It's supported. This may take some time. Yeah, woohoo! And now we have a profiling session, and perhaps we somewhere see. I'm not all too familiar with profiling just yet. But somewhere we will see our source generator. And we see we have here sometimes source information not available. That's actually, that's something else. That's for Microsoft Code Analysis. This is our syntax receiver, is it? It's the syntax provider, yeah. And there we say, okay, that's 0.13%. It's invoked once. That's cool. Yeah, and this is how we could both debug but also profile our generators. And this is, I wanted to add this as well, and I think this is, and one last thing I wanted to show, there were 2 points left. Yes, and the global tool in order to test the template. There is a global tool. Let's jump to the folder view. So in this repository, I have a .config .NET tools.json. In this file, you can add local .NET tools. Local .NET tools are basically part of the repository. So I can specify a specific version that I can then restore, and it's checked in, so it's part of the repository compared to a global tool. So this is not available globally, but it is available within this folder hierarchy. And let's go to the template pack. I think I need to run it here, not entirely sure. Perhaps I go to the documentation of this to refresh my mind, because it has been quite some time when I used it last. Let's check if there is a newer version of it available. 1.0.13, we have the latest version. And does it have some documentation? No. perhaps I have noted something in the notes of this benchmarking and of the .NET template session. Neither. Well, let's find out then. So the command is templates. So we can go and say .NET tool -- list. Is it just list? .NET tool list? Yes. Let's do a .NET tool restore first, that we're sure we have everything restored. So the command is templates. So we can say .NET tool. You see, we don't do the -G for the global tool because it's a local tool. I think you can just say .NET templates -- help. And this offers a search and an analyze. Yes, so I want to use the analyze tool. It analyzes the template if it follows best practices. And I wanna, this is like an analyzer for .NET templates. .NET templates analyze. Okay, but I guess, do I need to say like pass the project? Does it not work on a CS Proj, but on a template? Perhaps I need to go into the templates folder and run it here. Neither. Perhaps I need to go, I can't recall how we did this last time, into the generator here and run it here. If it shows nothing, is this good or bad? It's the last thing I would like to show. Let's see, perhaps I have some node or some link analyzers where I used this last time. But this doesn't yield any documentation. Damn it. Also, perhaps I can say analyze -- help. Woohoo! Okay, yes. Okay, so I could scan NuGet packages or folders. So I need to analyze -- folders. And okay, perhaps I need to jump out. No. Let's analyze a package. Let's do a .NET build .NET pack -c release. So we get here the path to the package, and let's say .NET tool analyze -p path to the package. Error, package not found, because it doesn't have all the full string. There we go. Cool. So what does it do? It's analyzing, it's extracting the zip, okay, it's validating the JSON files, and it doesn't, missing path. Okay, I have a missing path. Oh, there's already an existing issue, so I didn't introduce a new issue. I don't have a path for this. I'm not entirely sure what this means, but I will look into this. So before publishing this template, or updating this template is published already, but before updating it with the benchmarking enabled, I'll have a couple of to-dos. And then we'll publish this before the next stream, which is now a segue to the schedule. Because now pretty much 2 hours are over. I'm afraid we did not continue with the analyzer. This took a little bit longer than I actually expected. But we will definitely continue with implementing the benchmarking of diagnostic analyzers in the next stream, which is in a week from now. Same time, so it's in a week minus 2 hours, starting from 7 UTC. Where we'll briefly follow up on the template. Perhaps then I show the published version of it, and then we go back into, then we have the full story of benchmarking source generators and incremental generators complete. And we then have 4 types left to implement. We have the analyzers here. Let me jump to the project because I have somewhere an issue for that which tracks all of them. Yes. So we have now source generators and incremental generators complete. Next up are diagnostic analyzers. Perhaps then we do the suppressor or code fix first. Not sure yet, but we do have the we will continue with the analyzers next time, and then for future sessions we have the code fix provider, refactoring, and diagnostic suppressor also, and that then completes the C# journey of it, which then I would also like to implement the same, but for Visual Basic. I haven't written Visual Basic in 8 years. Yes, but perhaps it's possible still. Cool. Yeah. I guess. No, I don't guess. I know. This is it for it today. If I'm lucky, I will perhaps read you or in the chat next time again in a week, which is on the 7th of August on Sunday again at 7 UTC. And until then, may Roslyn be with you all. Thank you very much for joining. Goodbye.